Hello, welcome back. Fourier transform number 2. Fourier transform of an exponential pulse. Normally we use Fourier series expansion for periodic signals, GPT, piece for periodicity. That is Fourier series expansion. But Fourier transform here, Fourier series expansion. Fourier transform is normally applied for non-periodic signals such as the signal GT shown below. That means it doesn't have a periodicity, it's just a pulse in time domain with a certain amplitude during some time interval. The Fourier transform operation for a non-periodic signal GT is given by GT times exponential minus j2 pi ft dt integral minus infinity plus infinity is equal to capital GF. That is, the time domain function will become a frequency domain function. That is called a transformation from time to frequency. Similarly, the inverse Fourier transform operation for the frequency domain function capital GF is given by integral capital GF exponential j is, make sure this is positive, earlier it was negative, j2 pi ft df, and the integration with respect to f. Earlier it was with respect to t because the function was a time domain function. Now it's a frequency domain function. Integrate from negative infinity to positive infinity, then you get back the original time domain GT. Okay, obtain the Fourier transform for the exponential decay impulse shown below. This is the function given here. So what we are going to do here is to get a Fourier transform for a time domain pulse like this. This pulse decays with time. This time and this function GT. Let's see some notations before you proceed. First one, the unit step function, which is defined as ut, unit step function, equal to 1 when t greater than 0, equal to 0 when t is less than 0, but in between, that is when t equal to 0 it is half. This is by convention, otherwise it looks until 0 it is 0, when after t greater than 0 it will become 1, the step function. But if you define at t equal to 0, we normally take it as half. So therefore we can write an equation for the exponentially decaying function pulse here with the ut and exponential minus t. This exponential negative t is actually can continue for negative values of t also, which will be like this, go and then come that in this way. So but to get a function for exponentially decaying function here, we need to consider values of t starting from 0. Therefore, what we do is we multiply exponential minus t with ut, the step function. So when you multiply with step function, the values below 0 will become 0 because step function is 0 for values below 0. T equal to t less than 0, the function is 0. So when you multiply this step function with exponential minus t, you get a pulse like this. Now we can apply the Fourier transform equation, which is given by GF and GT. In this case, GT is equal to exponential minus t times ut times exponential minus j2 pi ft dt. So this is the definition. Definition says that gt times exponential minus j2 pi ft dt. So here you can see ut is there. Ut is a step function which has values from 0 to infinity. Minus infinity plus 0 is minus infinity to 0, the values are 0. So basically instead of ut being here, you remove ut and remove the integration minus infinity to plus infinity to 0 to infinity, because below 0 the value of the function ut is 0, therefore the whole function becomes 0. So therefore remove ut, change the units from 0 to infinity. Exponential minus t times exponential minus j2 pi ft dt. And then we can combine these two to get this expression here, exponential times exponential. So you take the minus out, negative time out, negative t out, times 1 plus j2 pi f integral dt. This is like exponential minus theta t. So this is a constant because we are integrating with respect to t. In this case, frequency is treated as constant, f a constant. So therefore, after integrating and putting the limits, we can see that when you integrate this one, it will become exponential minus t1 plus j2 pi f divided by 1 plus j2 pi f. So when you substitute for exponential t equal to negative infinity, then the denominator will become 1. Then it becomes 0 when it is infinity. When you put 0, denominator become 1. So basically you get 1 at the top here. So we can simplify and show this is 1 divided by 1 plus j2 pi f. That is the answer to this question. Basically this is the Fourier transform of a pulse, decaying pulse. The amplitude spectrum, if you draw this one in frequency domain, we can see that it has a maximum at 0 and it is like this. It's a function like this in time domain. So this is the function representation of the Fourier transform of the exponential decaying function. In other words, we can write the transformation gt become gf exponential minus tut will become 1 over 1 plus j2 pi f, or else the function in time domain will become a function in frequency domain, and this is the modulus of this function here. This is a complex number, but when you plot this one, you normally plot it as a modulus. So you can take some reference values, like we take f equal to 0, it will become 1. F equal to 1 by 2 pi, you can get this value 1 over root 2.